So welcome to our first chemistry virtual session. I haven't done a virtual session in so long. I'm sure that I'm going to be very confused today. So we'll work through this together. The first thing that I want us to go over is unit conversions and molar mass, right? These are the two hardest concepts from this first module. They're also concepts that we'll use throughout the rest of the class. So mastering these is going to be super key. In fact, what happens in this course is that we have these concepts introduced. We have some kind of basic chemistry stuff introduced, right? Some stuff that doesn't seem so hard. And then the last module is a real shift where all of a sudden it's hard math stuff for the whole end of the module, and it's right at the end of the semester, right? So it can be really stressful. So I'm going to try to ease you guys into that so that when you get to the math, it doesn't feel so bad, you're ready for it, and you can finish the class successfully. So we're going to be talking about unit conversions today and the metric system. And I know a few people have attempted this quiz already that's related to this content in Canvas. And even if you haven't attempted that, that's okay. We're going to talk about what that means and what you do. I would definitely recommend that you take notes during this, as the way that I set up these problems can help you set up problems in the future. So our objectives today are going to be to review the metric system, right? The metric system is used in science, and it's really easy to convert between units within the metric system, much easier than feet to inches or yards or any of those kinds of English system conversions that are always weird, annoying numbers. Metric system is based off tens. It's very easy. We're also going to practice dimensional analysis, right, which is unit conversions, essentially. It is a concept that if you continue to take science courses, you will use in college. And we're also going to review moles and how to convert from mass to moles and atoms. Again, that's something that you're going to touch on a little later in the year, but it's good to introduce now. And a little note, next week, there will be no chemistry virtual session. I'm going on the Columbia Gorge field trip to do water quality testing. Hopefully some of you guys will be on that field trip. But if not, we are not having a virtual session next week, which is why I want to do the unit conversions today. So I will also send an email reminder out about that, but just know that next week we will not have one. We will resume the following week. So where's my mouse? Let's talk about chemistry virtual session norms. Camera on, right? Christopher already just told me that he doesn't have a camera on his computer. So obviously that's going to make it impossible to have his camera on. But regardless, if you do have a camera, have it on so I know that you're there, right? You don't have to have your face in the center of the camera like I do. If you're feeling nervous or shy, right? You can always tilt a little bit. You could tilt up a little bit. Whatever works for you personally, as long as I can just tell that you're there and you didn't just log into my session and then walk away, which you're like, no one would ever do that. People have done that. Participate, right? I actually shut down a couple chemistry virtual sessions last year because nobody was talking to me. So participate. If you don't know, say, I don't know. If you're not sure how to do it, say, I don't know how to start this, right? But if you guys aren't working with me, then there's no point in having this session because otherwise it's just me talking. I could do that at any time. So make sure that you're participating, even if you're saying not sure, no idea. I have, no clue what to do in this question. Ask questions. A lot of these sessions I create based on things that I see people struggling with or that I get questions about. So either ask your questions in the session, or you can always email me and say, hey, I didn't understand this. Can you go over that in the virtual session? And I'll be happy to. Be respectful. Don't usually have problems with this, right? But of course, if somebody doesn't know something or they're not sure or they get it wrong, we're going to be respectful to them. Usually don't have to worry about that in chemistry, but you never know. And then some of the sessions will require pre-work. So pre-work sessions, I will usually send an email out saying, hey, the session that's coming up on this date is going to have pre-work, right? That might be reading an article, that might be trying an assignment, and then in the session we will talk about that stuff. Now, even if you forget to do the pre-work, come to the session anyway, right? You can probably get it done during the session, worst case scenario, or you can make it up. But some of them will have that, so be aware. Sometimes you will have to do something before you come to the session. Nice for you to join us, Evelyn. Oh, yeah, I know. I was just saying this was the first time I've used Zoom in like 4 months, so I'm going to be remembering how to use it. All right, so we're going to start with a warm-up. I want you to convert a kilogram into grams. And I'm not going to say anything else. So if you think that you should do this on the computer or in your head or using a conversion or whatever you would like to do, I want you to spend, let's say, a minute and a half right now trying to convert 1 kilogram into grams. And then I'm going to show you the most amazing shortcut of your life. So I'm going to be quiet right now while you think about this or Google this or see how to convert 1 kilogram into grams. Evelyn popping a question mark into the chat. 0.001 grams. 1,000, Christopher says. 1,000, Bella also says. Well, the correct answer is 1,000. However, Evelyn, you did the right thing. You went the wrong way with the decimal. So here is what we're going to do. Metric conversion chart. This is going to be your best friend in this class. It is so helpful. It's just moving the decimal. That's it. So this PowerPoint I'm going to upload into the course after we have this session along with the recording. I recommend you save this, right, or you write it in your notes or you find your own. I just took this from Google Images, right? Find your own version of this and save it. Take a screenshot, whatever you need to do to have this handy for you. The basic unit here is actually going to refer to a few types of units that we see in chemistry. And then we're going to talk about how to get 1,000 after we do that. Oh, Oliver also said 1,000. Sorry, I did not see that. So our basic unit, we have a few. We have grams. Oops. We have liters. We have meters. And we have seconds. Those are all units that we have probably heard of before, right? Those all are a version of the basic unit from which we start, right? It doesn't have any prefixes. All of these other things are prefixes. Milli, centi, deci, deca, hecto, kilo. Now this is the shortened version. There are more prefixes, right? So we might be expanding this chart as we go. For example, there's micro, right? There's mega, like you might have heard of megabytes, right? That is based off of this system. So in theory, if we're talking about computers too, you might also have bytes as a basic unit. So what we do to use this chart efficiently is, if we go back to the warm-up question, right? The question said convert, what was it? Convert 1 kilogram into grams. Right, so we're starting, wait, was that what it was? I hope so. Okay, regardless, whatever, we'll do that if it wasn't what it was, because I'm not gonna go back right now. So 1 kilogram to gram, how do we do that? Well, all we're gonna do is start with whatever prefix or unit we have. So we're starting with a kilogram, right? That means we're gonna start over here on this chart. We're going to have our 1, right? Because that's the number that we were given, it's just 1. To figure out how many grams we would have, all we're going to do is move the decimal however many times we need to get to the unit we want. So we're going from kilo to just regular grams, which is our basic unit here in the center. So I'm going to put a decimal point after my 1. And in order to get to grams, I'm going to move my decimal however many times I need to. So I'm going to need to move it 1 time for hectograms, 1 time for decagrams, and then 1 additional time to finally get to grams, which is my goal unit here. Well, then all I do is add zeros, which I'm drawing with my finger on the mouse pad, so excuse that my zeros are kind of ugly, but we get the idea here. So that's telling me that 1 kilogram is equal to 1,000 grams because I had to move the decimal 3 times, right? You might also think about it from the opposite direction, right? Which is sort of what Evelyn did. If we start with 1 gram, let's say we're starting with 1 gram and we want to know how many centigrams that would be. Centigrams is kind of weird because usually you think of centimeters, not centigrams, but it's the same concept. So take a second right now, see if you can figure that out. If we're starting with 1 gram, how many centigrams would be equal to 1 gram? Think about the decimal. Think about starting with 1. Think about where the decimal needs to move from this basic unit because that's where we're starting. Are we going to the right or are we going to the left? So interesting. A lot of people are saying 0.001, which I'm not quite sure why, but we'll talk about what the answer is, and then we'll see where we went from there. So we're starting at 1 gram. We want to go to centigrams. I find centigrams on my chart. I'm going to be moving my decimal 1, 2 places to the right to get to centigrams. I'm going to add 2 zeros. So the correct answer is 100. There are 100 centigrams in 1 gram. Now, if you just looked at this, which is what I'm guessing a lot of people did, you think, oh, well, it's 0.01. It is technically that from the basic unit, but we're not asking that, right? We're asking how many centigrams are in 1 gram. Well, centigrams are in the hundredths place. That means there's actually 100 centigrams in the gram, right? So you can't just look at these numbers here. They're actually kind of just telling you how much bigger or smaller this prefix is based on the basic unit, but it doesn't tell you how many centigrams, milligrams, etc. are in 1 gram. Another thing you might want to think about is, okay, if we have something that's smaller, are we going to have more of a small thing or less of a small thing? That's kind of a confusing question. More or less of a small thing? You're thinking, I don't know. Right? Well, it makes sense. Think about a ruler, right? If you had 1 meter, you have those big meter sticks. Smaller units are centimeters, right? You have a lot of centimeters in 1 meter. Because they're small, you need a lot of them to make 1 meter. That's the same concept here. You need a lot of centigrams, well, not a lot, but 100 centigrams to make 1 gram. So let's try 1 more. We're going to change the number from 1, so it's going to get a little harder. I'm going to erase a couple things here. So how about somebody in the chat tell me a number that you would like to convert here? 3. Awesome. So we're going to do 3 kiloliters. Liters are capitalized in chemistry, by the way. We want to know how many liters. No, you already did that one. How many deciliters is that? If we have 3 kiloliters, how many deciliters is that? Try the decimal moving thing, I'm telling you. Even if it doesn't make sense in your mind, start on this chart at kilo, see how many times you need to move the decimal. Okay, we've got a couple guesses. So let's see how many times we need to move the decimal. If we're starting at kilo and we need to go to deci, right? I'm gonna have to move my decimal 1, 2, 3, 4 times. So I start after my 3, I move 1, 2, 3, 4 times. I plug in my zeros, and I get 30,000, which I see a lot of people we got a couple 30,000s and we got a couple with either the wrong direction or too many zeros. So look at the answer that you put and think about, did you move the decimal too many times? Did you guess, right? Or did you move it the wrong way? Again, also thinking in your mind, is a decimeter smaller or a deciliter smaller than a kiloliter? Yes, right? It's smaller, which means there's going to need to be a lot of them to fit into 1 kiloliter. So 30,000 is going to be the correct answer here. Type a 1 in the chat if you'd like to do one more of these. And Evelyn's asking a great question. Yes, so if you're going to the left on the chart, the decimal goes to the left. If you're going to the right on the chart, the decimal goes to the right. That's exactly 100% correct. So we're going to do one more because I see quite a few ones. So we're going to do this time, we want to convert 42.3 milliseconds. We want to know how many seconds that is. So milliseconds to seconds. The lesson used another method. I wasn't planning on talking about it, Evelyn. If you have a specific question about it, we could talk about that based on your question. But this is the way that I like to do it. But the lesson does have another suggestion, if that makes sense to you. Really, I don't care how you're doing it. I just want to make sure that you know how to do it. So if the lesson method really resonated with you, then that's fine. So on the quiz, you can 1,000% use this, yes. Yeah, so I'm not concerned with how you do it. I'm more concerned with you have a method that works for you. So if this method, you're like, this isn't working for me, I have no idea, check out the lesson and see what they say, right? And then if that one doesn't make sense to you, then you can kind of figure it out. Yeah, I think this is easier because I love that it's based on tens, and moving the decimal is using that theory to your advantage. And you guys will see a lot of what I'm going to do in these virtual sessions is show you all the shortcuts, because there's a lot of shortcuts for chemistry. And I know all of them because I love shortcuts. Okay, so we've got 0.423, 0.0423. Okay, so we've got a 1 decimal discrepancy here. So let's figure it out. So I'm going to start by looking at where I'm starting. I'm starting at milliseconds, so I'm starting over here. I want to go to seconds. So I'm going to need to move my decimal to the left 1, 2, 3 times. So my decimal is already there for me, right? Because I have 42.3. So starting at 42.3, I'm going to move my decimal 1, 2, 3 times to the left. There's my very strange looking decimal. And I'm going to add a 0 there for my empty place, and I should get 0.0423. Now, does that make sense logically? Are milliseconds smaller than a second? Yes, right? So it would make sense that 42 milliseconds wouldn't be an entire second, right? We haven't reached a full second yet. So if it's a solid number, just a 3, we assume that the decimal is after the 3. Exactly. So if you have, let's say you have 100 as your number, you assume the decimal is at the end of your number, right? If you have 24.111, because ones are the easiest thing for me to draw, right? Then they tell you where the decimal is. So then you would move the decimal from wherever they gave it to you. But if you have a solid number that's not, doesn't need to be rounded, right? It doesn't have any tenths, hundredths, thousandths place, then yes, you assume the decimal goes at the end. That's a great question. Okay, good. So it seems like a lot of us got that one. Evelyn, do you see why you needed to move it one more place? I'm hoping so. And guys, this stuff is hard, right? So if you're feeling like, wow, this seems really hard, it gets easier. The more you practice it, the more you're like, okay, I get this, right? And it's okay to practice it and get it wrong. Oops, I didn't mean to erase the basic units, but oh well. Okay, So let's do one more, and then we're going to move on to the actual dimensional analysis section. And if we're still feeling kind of hesitant at the end of this, the next virtual session, I might do some more of this stuff as well, because most of you guys are not going to have a hard time understanding the vocabulary and the content, right? You're going to have a harder time with the math, is usually what I see. So our final one, let's say that we have, by the way, I don't really use hecto and deca because they're completely unrealistic for this class. You'll pretty much never see hecto or deca used, right? But they exist. So let's say that we have 400.11 meters, and we want to know how many millimeters is that. Good. I'm seeing two of the same answers. Also, I love that Oliver included units. Very important. I will tell you guys, units are important in this class. Even if you think, well, of course we know what it is. No, put the units on everything. So let's check and figure it out here. We're starting at meters, right, which is our basic unit. We need to go to millimeters, so we're going to need to move the decimal 1, 2, 3 times to get to millimeters. Starting where our decimal is, we're going to move 1, 2, 3 times. We're going to add a 0 in there, right? And we should get 400,110 millimeters, which it looks like everybody who popped an answer, everybody got that one. Awesome. Ooh. Okay, so that's how you can convert between metric system and all the units within the metric system. The nice thing is, I don't care about you converting to inches, feet, all that stuff. They may ask you to do that on the quiz. You can look up those conversions, right? For example, I believe it's like 2.56 centimeters equals 1 inch. You can look up those conversions online. However, in real science, we don't care about inches or miles or any English system unit because they're annoying. So, final thing I want to say is this. Now, all of that stuff that we just did, we can write that as a conversion factor. So, for example, remember that we figured out that 1 kilogram is 1,000 grams, right? Which we can easily see. If we started at kilogram, we had to move 1, 2, 3 places. So we end up having 1,000 grams. Well, those were equal. That means we can write this as a conversion factor. Now, the way that we will probably need to use that, right, is we're going to be canceling units out. So we're going to use these as fractions. And what's confusing about that is you can write this as 1 kilogram over 1,000 grams, or, oops, I was going to try to move that, but I don't think I can for some reason. Nope. There we go. Okay. We can write that as 1 kilogram over 1,000 grams. This essentially is 1, right? Because they are equal. So we can also flip that. We could write that as 1,000 grams over 1 kilogram. These things are the same. They are equal. Why? Because they are conversion factors, right? It's a similar concept in math where if you have 1 over 1, that equals 1. If you have 5 over 5, that equals 1, right? We are saying that these two things are the same, and it doesn't matter which way you put it. Now, that might seem like, I don't know what she's talking about. Well, this is going to come up in the next part that we do, right? So keep that in mind. These are conversion factors that we just found. So if they ask you to convert something from kilograms to grams, you would want to use this conversion factor in order to do that. Okay, so let's move on. All right, we are going to do the first two together. Then you're going to try to do the last one by yourself, and then we're going to check and go over it. So these are the kinds of questions that you will see, right? Convert 300 grams per milliliter into milligrams per kiloliter. Now, hopefully in your mind, you're thinking, who cares? Because essentially, we're going to be taking this answer that's 300 grams per milliliter, and we're going to be finding the exact same answer just in a different unit, right? A real world application of this would be that maybe we need to convert something in the medical field, right? For example, grams are pretty big. Maybe we need to know what it is in milligrams because that's the kind of tool we have to measure. Some of these are just for practice and they're not really practical units. Like kiloliters, you don't really see, right? Milliliters is pretty common. And you guys will kind of see that as we go through. So what I'm actually going to do is I want to make a table in here, which I don't know if I can do in Zoom. I don't think so. So I'm going to go into the PowerPoint and do it. Okay. So the way I like to do this online, right, because on paper it's a lot easier to write in fractions, is I like to do this in a table. So I'll insert, I can't see anything. There we go. Let's see, insert, do we have a table? Can I even do a table? There we go. I just like to insert a table. We'll make it kind of long. I don't think we're going to need it to be this long, where I can write my fractions. And I'm going to show you what I'm talking about in a second here. Okay, Evelyn, I'm recording, so you can watch the rest of this later, but hopefully I helped you with the metric system so far. Okay, so there we go. We have a table, right, which I'm just going to use in order to write my fractions. So the first step in doing dimensional analysis is figuring out what you know. That's always the first thing in any math question, right? Well, the only thing we know is this first number that they gave us. They gave us 300 grams per 1 milliliter. So this is how I would write that as a fraction. We're going to assume that this table line here is a fraction line. I want to convert this into milligrams per kiloliter. So that's what I need to get to at the end. So the first thing I am going to do is I'm going to start with grams, right? Well, I need to go to milligrams. So I need to ask myself, how many milligrams are in a gram? And I may need to go back to my metric system chart, right? I want to know how many milligrams are in a gram. Well, if I'm starting at 1 gram, I'm going to move my decimal 1, 2, 3 places to the right. I'm going to have 1,000 milligrams in a gram. So 1 gram is going to be equal to 1,000 milligrams. And all I did was use my metric system conversions to figure out that relationship, right? I did it kind of quickly because I don't want to go through that over and over and over with you guys because I think you were all kind of getting that. Now, why did I put grams on the bottom? Does anyone want to suggest or maybe has or knows maybe why did I put grams on the bottom? Because it's on the top in the first box. So what I'm doing is I'm setting up myself to be able to cancel out these units. Grams are gone. We're in milligrams now, which is great because that's what I want to be in for my final answer. Now, my milliliters isn't correct yet, right? So I still got to work on that one. But the concept behind dimensional analysis is that you set up your units so that you can cancel out your units and be left with the units that you want. So it's literally a long multiplication problem. There's going to be multiplication between each of these boxes. And I'm going to be canceling out my units. Okay, so we don't even do any math yet, though. We're going to set the whole thing up and do the math in one swoop. So I've gotten rid of grams. That's awesome. I'm in milligrams. We're happy with that, so we're not going to adjust that anymore. Now I need to move from milliliters to kiloliters. So that's going to be a pretty big jump here. So looking back at our metric system conversion chart, how many kiloliters is in 1 milliliter? How many kiloliters is in 1 milliliter? Well, we're going to have to go pretty far here. We're going to be moving the decimal 1, 2, 3, 4, 5, 6 places to the left. So it's going to be pretty small, right? I'm going to be going 1, 2, 3, 4, 5, 6. So 1 milliliter is equal to, come on, Zoom, let me write what I want to write. 0.0000001 kiloliters, right? And I can always check that. 1, 2, 3, 4, 5, 6. Perfect. Okay, that's a tiny number, right? So I need 5 zeros before my 1. So, oops. What I do in my dimensional analysis then is I use that conversion and I write that. And keeping in mind, I write so that my units will cancel out. So I have milliliters on the bottom, which means I'm going to want it on the top. So 1 milliliter was equal to 0.00001 kiloliters. Now, remember, that's an equal factor. You could always flip that around if you needed to, but in this case, that's going to work because my milliliters are going to cancel out now. So let me erase some of this, of like all these extra lines all over the place, which is a little confusing. There we go. So now I'm able to cancel out milliliters. I'm left with kiloliters, which is what I want. So I need to multiply all my numbers together. So why don't we all try that? You're welcome to use a phone calculator, a computer calculator. We're going to be doing 300 times 1,000 divided by 0.000001. Okay, so what I got is 3 times 10 to the 11th milligrams per kiloliter, right? So what that means is I have 11 zeros after my 3. Now, would you be wrong if you wrote out all the zeros? No, you could totally do that, right? You could also write it like this. Your calculator, if it says 3e to the 11, I know that's probably reversed for you guys, but if you have that e, all that means is that it's times 10 to whatever power that is. And that's just because the calculator can't display 11 zeros. So that's the answer to our first question, right? And again, that's a huge, huge number, but we had to do these 2 strange conversions. So it could be a little confusing to think about it. Is it bigger or smaller? In this case, it's kind of both. Okay, now let's try the second one. Type a 1 in the chat if you're feeling okay about what we just did so far. You're ready to see the next one. Type a 2 in the chat if you're like, what is going on? Okay, good. Most people saying 1. So we're going to move on then, to this next one. I guess I could have put my boxes in here before. That would have been smart. Okay, so now we're going to be converting 1 gram per hour into grams per seconds. Let's see, delete row. Oops, that's not what I wanted to do. Okay, delete column. Here we go. No. Okay, I'm just gonna leave that alone. I will clean this up later instead of messing with it right now. It just wants to delete the whole box. Okay, so we're gonna be converting grams per hour into grams per second. So this one's actually pretty simple. We're gonna start again with what we know. We know we have 1 gram per 1 hour. Now, you don't have to put this 1 in front of the hour, it's implied, right? But I like to put it because it helps me keep track of what I'm doing here. I like to have a number in every box, if possible. So I have 1 gram per hour, I need to get into grams per seconds. Well, what do we know about the relationship between hours and seconds? Do we know any conversions that could help us get to seconds? Minutes, sure. Do we know how many minutes are in an hour? 60, great. So we know that in 1 hour, remember I'm putting hour on the top because I want to be able to cancel my units out, has 60 minutes. And then what do we know about the relationship between minutes and seconds? One minute has 60 seconds. Right? So that's a conversion that we could already know. Now, some people might know, oh, well, I know how many seconds are in an hour. Great, good for you. Plug that in right away then. If you don't, you can break these down as many times as you need to. Right? So for example, if they wanted you to go from days to seconds, right? You could go from how many, like days to hours. There's 24 hours in a day. There's 60 minutes in an hour. There's 60 seconds in a minute. Right? And you could write out all of that and still get the correct answer. You don't have to know how many seconds are in an hour to start. So keeping that in mind, right? Well, in this case, let's make sure we're in the correct units. We're staying in grams, okay? Hours are going to cancel. Minutes are going to cancel. And we're going to be left with seconds. So in this case, we're going to do 1 divided by 60 divided by 60. And we get that our answer is 0.00027 grams per second. And when you're doing these math-wise, you can do all of the numbers on the top, multiply, and then divide by all the numbers on the bottom, right? You don't have to do 1 divided by, like, you don't have to do it in order as you go, if that makes sense. You could just, let's say we had 14 boxes, you could multiply all 14 things on the top and then start dividing by all the things on the bottom. You'll still get the right answer, which is nice. Okay, so then let's try this last one. You're going to try, you don't understand the last step, the multiplying. You're going to do 1 times 1 times 1, which is 1, divided by 1, which is 1, divided by 60, which is like point something, 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 divided by 60, which will give you this final answer. So you're just going to multiply everything on the top boxes and then divide by everything on the bottom boxes. Okay, great question though. Let's see if you guys can do this last one. So I'll give you about a minute and a half here. See if you can set up the last one or part of the last one. do as much as you can, right? You can do this on paper in front of you. If you'd like to try it in the boxes like I've been doing, you totally can. I am going to also work on setting it up. So what I'm going to do is I'm actually going to, no, I'll leave it up. I was going to say I'm going to stop sharing my screen, but I won't. So we're starting with 1,000 milliliters per 1 day, and we want to go to liters per year. And if you do get an answer here, go ahead and pop it into the chat when you've gotten one, right? And if you're not quite sure, that's fine. We're going to go over it together, but I'm going to give you guys another minute here to work on this one. All right, so let's start breaking this down. So where do you guys want to start? What was the first conversion that you used here? Are we going to start with milliliters or days? Okay, Oliver says milliliters. Great. So then I want to know how many liters are in 1 milliliter. So how many liters are in 1 milliliter? Does anyone happen to know that conversion? I know it's kind of hard when you can't look at the metric conversion chart. Well, okay, so Oliver, maybe you're doing 1 liter is 1,000 milliliters, right, is what I'm guessing? Yes, or you could do it that way. There's nothing wrong with that, right? Because those are in fact equal. You could also say that in 1 milliliter, we have 0.001 liters. So either way works, right? Some of these you'll just kind of remember. Like for me, I used 1,000 milliliters is equal to 1 liter because that's just a conversion that I remember because I've done this so many times, right? And I know milliliters are 3 places to the right from liters. So in my mind, I thought, great. Also, I noticed that I have 1,000 milliliters here and 1,000 milliliters here, so I could cancel those out, So you could do it that way. However, let's stick with, doing this where we start with 1 milliliter. And if we go back to our metric conversion chart, if we're starting at 1 milliliter, we know we need to move our decimal 1, 2, 3 places to the left, which tells us that, can't click, there we go, which tells us that we have 0.001 liters in 1 milliliter. So Bella, where are you lost? You're lost on the fact that we could use 1,000 milliliters in 1 liter? Yeah, so then don't worry about that. You can do it this way. There's multiple ways to do this. Some things are gonna click for people that don't necessarily click for you, and that's fine, right? This is the way that I personally would have written it out the first time that I ever did this. I usually go based on whatever unit I'm starting with, I convert from there. However, the way Oliver did it is 100% fine. Okay, so we know 0.001 liters are in 1 milliliter. Well, that will help us cancel out milliliters, right? And now we're in liters. That's great. That's where we want to be. And then we also want to be in year. So what do we know about the relationship between days and years? How many days are in a year? 365. So then at the top, I'm going to write 65 days are in 1 year. Now, my days cancel, right? Because day and days are the same thing. And I'm left with years. Well, I want years and I want liters. So it looks good in terms of units. Now I just have to do the math. So I'm going to do 1,000 times 0.001, which equals 1, times 365. And I should get, as my final answer here, that my conversion ends up being 365 liters per year as my final answer. 365 liters per year would be my final answer here. Okay. So that was our dimensional analysis basics. We are going to run out of time here because I want to make sure I'm being thorough on this. So we're probably going to continue working on this the next time as well. Would you be able to convert the 1,000 milliliters into liters, then times it by 365? Yes. So Evelyn, we just talked about that if you saw that you could put 1,000 here and a 1 up here, that would also work. You'll get the same answer. You'll get 365 days, liters per year. So let's try a final challenge question here. And then we will continue this in 2 weeks when we have our next session, right? Keep in mind, if you're getting this stuff wrong, it's okay. You're going to keep practicing. You're going to get it. You're going to be a pro. By the end of the year, when I say dimensional analysis, you're going to be like, so easy. Okay, so we want to do, well, here's like a word problem type situation here. You find a lot of pennies. How many dollars did you find is the first thing that we're going to find out. And if each penny weighs 0.01 grams, how much do your pennies weigh in kilograms? So let's start with the first question here. We're probably going to end up doing the penny weight one in the next session, but you're welcome to try that if you'd like. But how are we going to convert these pennies? We're talking 1 cent, yes. So pennies are 1 cent. How are we going to convert these into dollars? If we have 13,406,109 pennies, that's my unit. What do I know about the relationship between pennies and a dollar? We have 100 pennies in $1. Do we all agree with that? Hopefully. I do. So in that case, guess what happens? Pennies cancel. We're left with dollars. We're just going to take this big number here and divide it by 100. Now, knowing what we know about the weight, the next thing that we would do is we're actually going to convert this into a weight in kilograms. We're going to save that for the next session because we've already gone almost an hour here, if you can believe it. Okay, so do you guys want to continue doing more examples of this stuff in the next session that we have? And then Evelyn, I will address your question. Yes, yes. Okay, good. So we're going to keep doing this. So if you get to the unit conversion quiz and you do not feel ready to take it, skip it, right? I will not take any points off. I will not penalize you for skipping that. I'm not even going to put zeros in for that quiz yet until we've had our second session on this. Now, we don't have a session next week on September 18th because I'm going to be on the field trip. So September 25th, we will resume dimensional analysis work. And like I said, this is going to be the hardest stuff that we do for a while in the class. Evelyn's question is, do you always have to write down the charts? No, but I would. Why? Because most of the time it's not that simple. Most of the time they're not asking you to do one thing. Usually you're going to have at least 3 things that you have to multiply. And if you just try to do it in your head, you're going to make careless mistakes. I always write everything out, and I always literally cross out my units. Like I just did that 365 days one on paper by myself. I always cross my units out. It's just a way to double check that you did the correct math. Okay. Thank you guys for being patient with me. I know some of these sessions are going to be a little intense because it's going to be math. But I'm going to do my best to help you guys through all the math so that you feel confident when you're doing it on your own. Any more questions about the stuff that we've done so far or what to expect for next time? Oops. I'm like struggling with Zoom. I have so many things open. Okay. Okay, awesome. Well, then I will see you guys on September 25th. If you get stuck on anything else during the class, right, or you have a specific question on a certain one of these that you see on the quiz or in the lesson, send me an email, right, and I will get back to you really quickly. I'm pretty fast with email. All right, otherwise I will see you guys on the 25th.